This is Akshay Jha from Team 11 L Division, and today I will be giving a presentation on our engineering exploration course project Clean Mode. The team consists of me, Sumed Nilakhe, Suyesh Dikori, Gautam Ramanand Nayak, and Ashutosh Kumar Singh under the guidance of our mentor Ms. Unnati Kopikar. Now, our point definition says, design a semi-automatic floor cleaning machine which runs on battery, is lightweight and user controlled. It should do hygienic cleaning of the floor and should be portable and user-friendly. Machine should be able to clean an area of 4 x 4 feet in less time, and the budget to build it must be less than Rs 2000. Dimensions must be 1 x 1 feet and should be able to work for 3 hours continuously. Machine should do dry and wet cleaning of the floor and be able to sense and avoid obstacles. It should be able to spray antiseptic cleaner on the floor and also collect dust. Now, according to the function tree, there are 3 main functions: cleaning, storage and movement. In cleaning, there are sub-functions like spraying water, collecting dust and cleaning mode, which will be mopping or vacuuming. In storage, there are sub-functions like water plus disinfectant liquid storage as well as dust storage. And in movement, the sub-functions include sense obstacle, avoid obstacle and user interface. Now, when we clustered the functions, we noticed that there were 3 main clusters, namely cleaning, storage and movement clusters. Therefore, we were able to identify that the subsystems are cleaning unit, storage unit and movement unit. Now, let's take a look at the concepts which were generated by me and my teammates. In concept number 1, the main things are that the cleaning is done with the help of a vacuum and a removable broom, and there is a photoelectric sensor. Now, in concept number 2, the cleaning is done with the help of a cloth brush, a vacuum and a water spraying machine, and the obstacle detection is done with the help of an ultrasonic sensor. In concept number 3, the cleaning is done with the help of a scrub mounted on a servo motor as well as a vacuum bottle. In concept number 4, the cleaning is done with the help of a dust collector, a brush and a sprinkler. And finally, in concept number 5, the cleaning is done with the help of a sponge, a water sprayer, a vacuum cleaner, and the obstacle detection is done with the help of IR sensors. Therefore, after looking at all 3 designs and using the bug chart, we were able to select concept 5 as our concept. Now, coming to virtual implementation. I have created a video on the 3D model of the entire system. Let's take a look at it. So, this is a 3D model which consists of this chassis. The chassis is fixed with the help of these L clamps as well as nuts and bolts. These LEDs are used for obstacle detection. Now, this vacuum cleaner allows for the suction of dust, which is done with the help of this fan present inside. Here is the fan which helps in the suction of the dust. Now, let's take a look at the wheels. As you can see, there are 2 front wheels, each driven by a single DC motor, which allows the bot to move in forward, backward, and left and right directions. You can also see the behind 2 wheels or the back wheels, which are follower wheels. Now, we'll take a look inside and see what all components are present inside the bot. This is the mop, which is driven by a single DC motor, which allows this mopping of the floor. And next to it is the cylinder, which is a water sprayer. It consists of a DC submersible pump inside it. Now let's take a look at it. As you can see, this is the DC submersible pump, which allows the water to be sprayed. So whenever we want, we can switch it on and spray water. Now, we will take a look at the bot from all the various angles. As you can see, this is a side view. Now, let us take a look at the front view. As you can see, this is the front view. Now we will take a look at the top view. This is the top view of a bot. You can see the vacuum cleaner on the top. Now let us take a look at the bottom view. As you can see, this is the bottom view. You can notice the mop as well as the DC motors as well as the vacuum nozzle and the cylinder which contains the DC submersible pump. Now the last view will be the back view. So let's take a look at it. This is the back view of a bot. This concludes a 3D model. Now this is the circuit diagram of our entire system. It consists of 4 DC motors joined with the help of L298N drivers as well as a DC submersible pump, and it contains 2 IR sensors. This is a Simulink model. This is the flowchart or chart. This is a zoomed version of the chart. Now let us come to bill of materials. This is the movement subsystem bill of materials. It consists of all the different parts of the chassis as well as the IR sensors, the wheels, wheel shaft, L clamp, bolts, nuts, DC motor L clamp and the motor drivers. This is the bill of materials for the cleaning subsystem. It consists of DC motors, DC submersible pump, a vacuum cleaner, etc. And this is a storage subsystem which consists of a water storage can. Now let's take a look at the motor sizing and battery sizing. We did motor sizing for our entire system to determine the exact specification of the motors required for each function. Now let us check wheels. For our wheels, we did the calculation and came to know that we require 230 RPM DC motors for the front wheel. When it comes to mop, we did some more calculations and found out we require a 100 RPM DC motor for the mop. Third, for the vacuum cleaner fan, we require a 1000 RPM DC motor, whereas for the spring water pump, we require a 700 RPM mini DC submersible water pump. Now let us come to battery sizing. After doing calculations, we got to know that we require a 2.25 ampere hour battery to run our bot for 1.5 hours. Now let us come to the function specifications of our system. The functions include sensing obstacles, that is, the sensing should be done within 2 cm to 10 cm. Then the second one is vacuuming, that is, the vacuum will suck the dust at a distance of 3 cm and the mouth will be inclined to the base at an angle of 60 degrees. Third is the movement, that is, the wheels are rotating at 30 rpm and moving linearly with a speed of 0.157 meter per second. The fourth will be spraying, that is, the water will be sprayed at a distance of 4 cm and the water flow is 80 liter per hour. Fifth one is the cleaning. It will clean an area of 4 x 4 feet within a minute. The last one is user interface, that is, our bot will accept commands from the user via Bluetooth through an app. And here we come to modeling and simulation part. So let us get down to it. As you can see, this is a Simulink model. 1 and 2 pins are for the mop, 3 and 4 pins are for the water spray, 5 and 6 pins are for the vacuum cleaner, 6 and 7 pins are for the front left wheel, and 9 and 10 pins are for the right front wheel, whereas pin number 19 is for the LED. Now initially it is at state 5, that is, everything is switched off. Now let us move the bot in forward direction, that is, by giving the input 1. So when we give the input 1, you can see that the left front wheel has 1 and 0 and the right one front wheel also has 1 and 0. This indicates that the bot is moving in forward direction. Both the left and right wheel are moving in the forward direction. Suppose we want to move the bot in backward direction. So we will give the input as 4. So giving input as 4, we can see the values change. The left front wheel now has 0, 1 and the right front wheel also has 0, 1, which indicates both the wheels are moving in the backward direction. Hence our bot will move backwards. Now let us suppose the bot is moving in forward direction. So we give the input back as 1. Now the bot is moving in forward direction. Suppose we want to switch on the mop. So we will give the command as 6. So when you give the command as 6, the bot is moving in forward direction as you can see, and also the mop is switched on. As you can see, pin number 1 and 2 have values 1 and 0. That is, the mop is switched on. Suppose we want to switch on the water spray as well. So we would give the command 8, that is for water spray. Given the command as 8, let us see what happens. Now when we give the command 8, you can see pin number 3 and pin number 4 have value 1 and 0. So the bot is going in forward direction as well as both mop and water spray are switched on. Now suppose we want the bot to move to the right. So we give it the value 2. So after giving the value 2, the bot starts moving to the right. The left front wheel has value 1 and 0, whereas the right front wheel has value 0 and 1. Therefore, the bot turns to the right and both mop and spray are still on. As you can see, mop and spray are still on. Now suppose an obstacle is detected by IR1. So the obstacle detection value becomes 0. So given the value as 0, we see that the LED starts to glow. As you can see, the LED value becomes 1, which indicates the LED has started to glow. Everything else, all the other values are 0, which indicates everything else is stopped. This concludes our modeling and simulation video. Now, with this, I would like to conclude our presentation. Last but not the least, I would like to thank all our teachers as well as my mentor for giving us this wonderful opportunity to do this project. We learned many things from this project. First and foremost, we learned how to work as a team and make deadlines and adhere to them, and also divide our work amongst and be able to achieve our goal. Second is, it helped in our skill development. We worked on 3D models on the Inventor software as well as the Simulink models on the MATLAB Simulink software, and these skills are valuable and will help us further on. Last but not the least, we were able to brainstorm together as a team and come up with many possible solutions, as well as decide on one solution which we did and helped the society as a whole, and also were able to meet the requirements of our client. Thank you for watching.